Hi guys, and welcome to section 5 of this course. In this section, we'll be taking a look at databases on the Amazon Web Services platform. Specifically, we'll give you an introduction to databases on AWS. We'll then move on to taking a look at the Amazon Relational Database Service, RDS. Next, we have Amazon DynamoDB, which is Amazon's NoSQL database solution on the AWS platform. We'll then follow that up with Amazon Redshift, which is our data warehousing solution on AWS. And finally, we'll end by taking a look at the Amazon ElastiCache service, which is our in-memory caching engine on AWS. So in this particular video, we'll give you a quick introduction to databases on AWS, and we'll get started. Now, databases tend to provide a backbone service for your applications by storing terabytes to petabytes of data that ultimately make our applications purposeful. Amazon Web Services offers a range of database services that enable your applications to access this data with millisecond latency, process millions of requests per second, and scale to support millions of users anywhere in the world. Databases contain the raw data of all of your transactions or captured data, which can then be filtered, sorted, and queried to derive meaningful information. So there are different types of databases available on the Amazon Web Services platform, and we'll start by taking a look at the most common traditional style of database system, the Relational Database Management System, or RDBMS. Traditional database management systems store data in one or more tables formatted into rows and columns, where the column is similar to that of an Excel spreadsheet column, and rows will contain individual records within that table. Now, each row will also have a primary key, which can then be used to identify individual records in the database and can be used to cross-reference records in other tables through a process of normalization. Next, let's take a look at non-relational databases. Now, these offer flexible schemas for building modern applications. They're widely recognized to overcome some of the limitations associated with traditional relational databases due to their ease of deployment, functionality, and performance at scale. NoSQL databases offer the ability to scale horizontally and can be modified dynamically far more easily than traditional RDBMS systems. There are various types of NoSQL databases, including document stores, graph stores, key value stores, in-memory engines, and search databases. Now, the one thing that I'd like to point out here is that non-relational databases are also known as NoSQL databases. However, SQL is actually a language, and you can definitely use SQL, to query both your relational and non-relational databases. The term NoSQL actually implies not only SQL. Okay, so next I want to take a quick look at the differences between relational databases and non-relational databases. Now, with relational databases, data is stored in one or more tables, and generally you'd create different tables for different sets of data that may or may not have a direct relationship between them. For example, in the screenshot shown, you can see that we have two tables. One's an author table and the other is a book titles table. So each table will have a column that contains a primary key. So in the authors table, we have the author ID, and in the books table, we have the ISBN number. The records from one table can then be linked to the records in another table by linking these keys. For example, in the second table, you have the unique ISBN numbers that uniquely identify every book title. However, because several books could be written by the same author, you're able to link multiple books to a specific author ID. Then you can easily run queries to list out books written by a particular author. It is important to understand that with relational databases, you do need to define one or more relationships between tables, as well as define the data types used in each table. This is what we call a schema, which needs to be defined clearly before we start adding data to our tables. Now, on the right-hand side, we have our NoSQL database, something like DynamoDB. The primary key for the music table consists of two attributes, namely the artist and the song title. In this example, each item in the table must have these two attributes, and the combination of the artist and the song title uniquely identifies each item in the table. With DynamoDB, you only need to define the primary key. The music table is otherwise schemaless, which means that neither the attributes nor the data types need to be defined beforehand. Each item can have its own distinct attribute. You can have nested attributes as well, and there's support for nested attributes for up to 32 levels deep. In addition to that, you actually have two types of keys in a NoSQL database like DynamoDB. We have a primary key, otherwise known as a partition key, and we have a composite key that comprises of a primary key and a sort key. I'll be talking more about DynamoDB in a lot more detail in an upcoming video. Okay, next I want to take a look at the two options that you actually have available to host your own database management systems on the Amazon Web Services platform. Now, you can use the Amazon RDS service, which is a managed service, or you can also set up and launch EC2 instances on which you can launch your own databases. Now, RDS is a managed service, meaning that you do not have to install the database on a server. Likewise, much of the underlying infrastructure and configuration is done for you. But you do have the option to select the infrastructure that powers your database. For example, you get to select the instance type, the storage level, and whether to back up your database or not. It is actually possible to install your database on your own EC2 instances, much like you would install a database on an on-premise server. And there could be different use cases for this, including the fact that you're trying to use a database that is not RDS compatible. However, unless you really have a good reason, it makes a lot more sense to opt for the RDS solution with regards to provisioning relational database solutions on the AWS platform. As you can see, there are core differences between hosting your own database on an EC2 instance versus hosting an RDS solution, as the RDS solution takes away a lot of the management overhead in maintaining your database solution. Short of ensuring that your applications are optimized to use RDS, you can pretty much leave most of the management, scaling, disaster recovery, backup, etc. to be managed by AWS itself in the back end. So with regards to relational database services and Amazon RDS, we actually have 6 different database engines available. We have Amazon Aurora, MySQL, PostgreSQL, MariaDB, Oracle, and the Microsoft SQL Server. These are what we call transactional databases, specifically online transactional processing databases, or OLTP. On the AWS platform, we have another type of relational database service called the Amazon Redshift service. Now, Amazon Redshift is a fast, simple-to-use, petabyte-scale data warehousing service. It delivers 10 times better performance than other data warehouses and uses massively parallel architecture to deliver throughput and sub-second response times. Redshift automates most of the common administrative tasks to manage, backup, monitor, and scale your data warehousing solution. Redshift is what we call an online analytical processing databases, or OLAP. We'll take a look at Redshift in a lot more detail in an upcoming video. So we briefly mentioned non-relational databases earlier and how they work when compared to relational databases. On AWS, we have DynamoDB, which is our NoSQL database service. Now, this is a fully managed database solution that takes away all of the administrative burden associated with configuration, replication, software patching, and cluster scaling. With DynamoDB, we also have tables that contain items and attributes. A table is a collection of items, and each item is a collection of attributes. DynamoDB uses primary keys to uniquely identify each of the item in a table and secondary indexes to provide additional flexibility for queries. DynamoDB lends itself well to act as a data store for solutions such as mobile, web, gaming, and Internet of Things application. We'll discuss DynamoDB in a lot more detail in an upcoming video. Finally, we have another non-relational database service, which is the Amazon ElastiCache service. Now, Amazon ElastiCache is a managed service that is easy to set up and scale in memory distributed cache environments. You get cost-effective caching solution without having to design, deploy, and provision your own caching environment. 2 engines offered are Memcached and Redis. You can run your caching services in an Amazon VPC, and you can easily add nodes, clusters, and read replicas to scale. Right, so that brings us to the end of this introductory video on databases on AWS.